Question 1. Study figure 1, a graph showing the changes in the amount of carbon dioxide in the atmosphere. So I've got a graph, and the first question is to describe the change in the amount of carbon dioxide in the atmosphere shown in figure 1. The key word is describe. Now what we need to make sure we avoid saying is really basic statements like the graph goes up or the amount of carbon dioxide goes up. Because although that is not false, we need to be a little bit more specific. So for instance, we can see that the line from 1850 to 1950, it was a fairly steady increase, or it increased slowly. And after 1950, it increased a lot faster. Now that will get you 1 mark. Your second mark is for use of data. So, you've always got to see the figure and think, right, what can I use? What do I need to use in my answer? So, for instance, you could say that from 1850 all the way up to 2010, it's gone up over 100 parts per million. Question 1.2. Outline one reason why the concentration of carbon dioxide in the atmosphere has changed over time. So just to remind ourselves, the amount is going up. So basically, why is there more carbon dioxide in the world than there was before? So got to do one reason, as the question suggests, and then just develop it using phrases like which means that, because. So for instance, a very common answer would be there are more cars in the world. Cars burn fossil fuels, and it's these key terms that we need to include, otherwise our answers are going to sound too vague and potentially not get the marks. So cars burn fossil fuels which release greenhouse gases such as carbon dioxide. You could have a very similar point about the factories or the power stations giving off greenhouse gases. Another point would be what we've got here, deforestation. So the cutting down of trees. Because what trees are, they're called carbon stores or carbon sinks. They store the carbon. So if there are fewer trees in the world, there are fewer places to store the carbon, so more of it will be in the atmosphere. Just looking at the mark scheme, it does say they allow natural factors as well, not just the human ones. So you can have things like there's lots more volcanoes erupting, giving off carbon dioxide. (1.3) Using figure 2, which two of the following statements are true? Shade 2 circles in only. So figure 2, you've got a map of the world with loads of different colours on. These colours show different increases in temperature of the surface of the world, and what they think they're going to increase by 2070. So the correct answers are C and D. So let's just double check. C, temperatures over most of the sea areas north of 60 degree north are expected to increase by 4 degrees, which is the orange colour. So let's double check. 60 degree north, you've got all of the sea here, all of the sea here is orange, which is a bit around us here in the northern part of the Atlantic, but most of it is orange, which is 4 degrees. And then D, temperatures over the whole of Africa are likely to rise by 3 or 4 degrees. So is Africa yellow and orange? Yes, it is. So obviously, this map has no place or continent names on it, so you are going to have to know where these places are. Otherwise, how do you know if that one's right or wrong? Just be careful though, because I've seen a few people do this in the past. It's really frustrating and easy marks are lost. No credit if 3 or more statements are shaded, or what is just as likely is if you just shade one in. So just be careful. 1.4, the weather of the UK is becoming more extreme. So we've got a statement there. Use evidence to support this statement. So the word evidence means we need some specific examples. So is the weather in our country getting worse? Essentially is what it's asking for. 6 marks. Now you've probably heard us talk about level 3 answers. These are 5 or 6 out of 6. We need to provide a balanced discussion with well-developed ideas through a detailed understanding of the issue and demonstrates thorough understanding of the evidence for increasing extreme weather in the UK. So we've had this question, I think, in a few mocks. A few of you haven't talked about the UK. You've just been very general with a pattern of weather. That won't get you many marks for this question. So in terms of our evidence, we first of all, I know it's a few years ago now, but we've got the Boscastle flash flood. So you could include that here because that is our UK-based hazard. But loads of rain fell due to the steep slopes and the deforestation. The town of Boscastle was severely flooded very, very quickly, and maybe talk about some of the impacts. But there are more things as well, certainly more up-to-date examples that we can use. So just think back over the weather simply over the last few years. We had the Beast of the East, sort of February, March time 2018. You had the huge European heat wave in the summer of 2018. You even had a few days in February 2019 for the first time ever since records began that reached 20 degrees Celsius. Because normally in February we don't get temperatures anywhere near as warm as that. So there's loads of different specifics that you can include here. It's quite a tricky one, this question, in terms of finding out where the balance is. So what we ideally would be after for sort of the top marks is saying, yes, there's been the Boscastle flood, yes, we have the Beast of the East and the European heat wave. However, does this show that the UK's weather is becoming more extreme? Well, it might do, or these might just be sort of one-off events and not pointing to any long-term pattern. So some of these questions I'm not a big fan of because that's very sort of difficult to try and get to. But try and understand that in most 6 markers, you will need some balance. And that bit, just to say that the pattern might be there, but it might not be, that would be enough just to tip you into that level 3 answer. 1.5. Complete the following sentences. The greatest number of Category 4 tropical storms happen in the what ocean? So you've got your figure, which again is a map. It's a slightly different map in the sense that it's not UK centred. So we're normally in the middle, but what they've done is they've just shifted the map slightly. So we're over here now, you can just about see just behind the lines. So this might confuse some of you because you're often used to seeing the Atlantic Ocean in the middle of the map. The Atlantic is a big body of water between us and America. So on this map, that's that bit here. So this big ocean here between America and Asia and Australia, this is called the Pacific Ocean. Now we know there's a lot of Category 4 storms by the orange colour here. So basically, what ocean is most of the orange lines in? And you can see sort of this section here. So 1 mark for saying the Pacific Ocean. And apart from strong winds, one other associated weather feature of a Category 4 storm is what? So you've got winds, as it says, you've also got rain. But what you must do is you must quantify the rain. You can't just say, and it gives us rain, because you don't have to have a hurricane to get rain. So you have to say it's either, their answer here, heavy rain, intense rain, or torrential rain, but you need some sort of adjective before the word rain. 1.6. Give one condition that is needed for a tropical storm or hurricane to form. So we're only after something quite basic here because it's only 1 mark. So looking at the mark scheme, interestingly, it sort of suggests that you can get the mark just by saying an area where you've got hot water, where you've got warm sea temperature. I would always be inclined to give that sort of magical number of 27 degrees Celsius plus, just to make sure you've got enough detail for 1 mark. If you don't want to say that one, other things you could say is maybe you need winds near the ocean surface basically coming together, and they've used the word converging, so the winds come together. Or you could say to create a tropical storm you need something called low wind shear, which basically means that the wind speed near the surface of the ocean and high up in the atmosphere are fairly constant. They're fairly similar. But out of all those, I guess one of the most obvious thing to think about is where the hurricanes, the tropical storms form. Well, they form out in water. That water's got to be at least 27 degrees Celsius. 1.7. Using figure 4 only, forecast the weather conditions in New Orleans over the next 24 hours. So 4 marks, so we're after a couple of detailed points here. So you've got your satellite image, and just by chance, obviously we do Hurricane Katrina as a case study, and this is basically what this satellite image is of. Again, look at the figure and think to yourself, what is there on there I can use in my answer? So it's a couple of things I'd just like to point out. You've got the north arrow here, so perhaps we can use compass points, north, east, south and west. We've also got a scale down the bottom, so maybe you could talk about the size of the storm potentially, but it's really focusing on the weather conditions. But the word only is interesting. We've really got to link this closely to this image rather than, again, talking quite generally. To get top marks, level 2 in this case, you've got to demonstrate accurate interpretation of the weather conditions and make clear and effective use of the satellite image. So, first thing you could say is cloud cover would increase in New Orleans. And this is a part of your answer that a lot of you sort of skipped when we've done this one in the past. You've gone straight to sort of rain and wind. But first of all, before that, you know, a hurricane is a huge, massive cloud. So clouds will increase. If you really want to go specific, you can spell this one correctly. There's a word here, cumulonimbus. These are the really big storm clouds that they often get in this part of America. So you could say clouds can increase, such as these cumulonimbus clouds. It's then going to bring heavy rain, particularly from the outside of the hurricane. These are called the rain belts. So when they're above you, absolutely chuck it down. Then as the eye wall, sort of the outer part of the eye is over New Orleans, the wind speed is really going to pick up. We're talking hundreds of kilometers an hour, potentially. Now, to use figure 4 to be as specific as possible, ideally we need to be talking about where the sort of cloud and where the rain is going to come from in terms of direction. Now, we know, because we've done this case study, that this is above the equator. So the hurricane will be spinning in an anti-clockwise motion. So for instance, following the cursor, this is the way that it will spin, in this direction, round like that. So what you could say is New Orleans, you could say that the cloud is going to come from the east and then it's going to pass over like that. So the clouds from the east and then the rain and then the wind. As the hurricane goes through New Orleans, you might have a period of calm when the eye of the storm is above you. And then you could say, obviously, once the eye is passed, you're back into the eye wall in the other part of the hurricane. But this time, if you can imagine, that the weather is going to come from the west as it snakes around in the anti-clockwise motion. So if this hurricane is there, it's going to snake around. So the weather comes from a different direction. You can also say, obviously, in 24 hours, this is likely to pass. We know hurricanes lose their energy as they hit land. So you could say that the weather then starts to calm down, the level of cloud cover then also reduces. And finally, maybe you could talk about the air pressure as well, because before the hurricane, you're probably going to have high pressure. The hurricane is a massive low pressure storm. So if you can think about all the air rising up, and that rising creates low pressure. So you could say that hurricane brings the low pressure, and as it leaves, the pressure will then rise back up again. 1.8 give 2 reasons why tropical storms eventually lose their energy. So you've got 1 mark for each of our 2 brief reasons. Okay, so the first one could be the idea that hurricanes can move onto land. Why does it slow them down? Well, sort of the key word here is friction, or the frictional effect of moving over land. So e.g. they pass over land which slows their movement due to friction, and that'll be fine for the mark, but just get that word in, friction. The second point, I guess sometimes we sort of forget this, but most hurricanes don't hit land at all, but obviously they're the ones that we hear about because they cause all the damage and destruction. So it's all to do with the temperature of the water. As we know, it's 27 degrees plus for hurricanes to form. So as hurricanes spin away from the equator, what is going to happen to the temperature of the water? Well, it's going to cool down. It's going to be less. So the key sort of phrase here is if the water is cooler, there is going to be less rapid evaporation. That is where the water is heated up and turns to water vapor, and the water in the air starts to rise. That is going to happen slower. So include the idea that water is colder, so then there is less rapid evaporation. Finally, I know a lot of you, so this is sort of your go-to answer in the exams. You talk about the fact there is no water on land, but there is. Do we have rivers? Do we have lakes? Yes. So try and avoid sort of sweeping statements. You could say, there is less water on land, therefore there's going to be less rapid evaporation, but always try and link it to temperature, because that is one of the main drivers of a hurricane. So when it's cold, obviously less rapid evaporation, and eventually it will just lose its energy. 1.9, choose either an earthquake or a volcanic eruption. Assess the extent to which primary effects are more significant than secondary effects. Use figure 5A or 5B and an example you have studied. So your first 9 marker will always have the +3 spelling, punctuation and grammar marks as well. So take time on this question because it's worth an awful lot. But a lot to break down from this question. First of all, yes, we have sort of studied both in terms of how they are formed, but at GCSE we've only given you case studies for earthquakes. The last time we did a volcano case study was probably Mount St Helens way back in year 8. I know a few of you seem to always want to reference in the exam, maybe to get confused with Dante's Peak, but forget a volcanic eruption. If there is a choice, we are doing earthquakes. Now, this question, like most 9 markers, needs you to evaluate. You need to have some sort of balanced argument. This phrase here, assess the extent, or questions might say to what extent. It's basically saying, do you agree? So in this case, do you agree, or how much do you agree that the primary effects, those things that happen straight away, are more significant, are basically worse than the effects that happen later on, knock-on effects. So we've got to use the figure and an example you have studied. 2 examples that we've got the Haiti earthquake and we've got the New Zealand earthquake as well, and also the figure. So one is linked to earthquakes, which will be this one here, and this one looks like it's a volcano. So we ideally would be referencing the first one, 5A. So to get level 3 marks, that's at least 7 out of 9. You've got to demonstrate detailed knowledge. You've got to show thorough geographical understanding and demonstrate application of knowledge and understanding in a coherent and reasoned way. So basically, do you know your evidence? Can you explain it? And can you evaluate it? So this is what we're after. So, excuse me. In terms of Haiti then, 220,000 people died, roughly. Now, a lot of those people died straight away. The buildings were really, really poor. there was a earthquake that measured 7 on the Richter scale that basically collapsed a huge quantity of buildings, and as a result, loads of people died. So that is a primary effect. So I would be suggesting that you write that the primary effects are incredibly bad, particularly in poor countries, our LIC countries, because this is how most people die straight away. However, here's how we get the balance in. Not everyone died straight away in Haiti. If people had injuries, then they would attempt to seek medical attention. The problem is one of the main hospitals also collapsed in the earthquake. So a lot of people died either of their injuries or due to a disease called cholera. And that was later on. They're the secondary effects. In total, though, cholera was around about 9,000 people. So, what's worse, basically? Over 200,000 people died straight away, or the 9,000 that died afterwards. So, assuming you'd be writing that the primary effects are worse in that sense. However, maybe we could talk about the fact that secondary effects are also really bad because, in places like Haiti, they're not going to have their own money to fund it. This is one of the poorest islands in the entire world. So they're crying out for help from America, from other Caribbean islands, from Europe. And this is going to take a long time for that money to come because they can't sort the problem out themselves. If you wanted to, you could obviously talk about the New Zealand earthquake and say, actually, 2010, nobody died. So the primary effects weren't that serious at all. And the main reason being they had lots of earthquake-proof buildings, had those cross bracings, they had shock absorbers, they had the money and invested it because they get hundreds of earthquakes every year. Secondary effects, again, just like Haiti, what is going to be a big secondary effect? Well, it's going to be the money. Obviously, New Zealand are a HIC, they've got the funds, and the disruption was minimised by the fact that they could sort it out straight away and get people back to school and work fairly readily. Now, that was using our example. Using figure 5a, ideally, you've got to make this obvious to the exam marker because they might have marked around 200, 250 papers before they get to you. And it's a human doing the marking. It's not a robot, it's not a computer. So I would just make it really obvious. And when you're talking about a case study, I would also be saying, as well as in my case study, I can also see in figure 5, I'd actually write that in my answer, that buildings are destroyed, which would have killed probably a lot of people straight away. So this is a primary impact. So I would definitely be saying in figure 5, I'd be being really, really obvious and saying, I have used the source and this is where I've done it. Now, for a lot of you, you either sort of run out of time here or just run out of steam because you just see a page with lots of lines and you get a bit frightened. But just try and break this, questions like this down. And I think what would help a lot of you is if you actually conclude it first and, use that opening paragraph almost as like your conclusion, and I will act hopefully as a plan for the paragraphs below it to basically evidence and explain your first paragraph to conclusion. So that could be a good way to go. But again, spend time on these questions, 12 marks, a huge percentage of your paper. So hopefully do a good job on these.